Hello and welcome back to the show. My name's Relevant. This is Do All the Things. And on today's episode, part 2, we are working on the train box for the PCC, TTC, PCCC streetcar. The circuit I explained in the last video, I'm going to start building on it today. So what does this entail? Well, parts. Already seen on this circuit. I'm already using some of the parts I'm gonna use, like this potentiometer. A P0915N, key term 5N, that is this orientation we have here. A linear 100K potentiometer with a smooth shaft, that's gonna be 15 mil. And then this thing, which I do believe is the 24mm Adafruit arcade button. It's got a very nice cushy feel. It's gonna be fun. Illuminated, it's got 2 white LEDs in it. And I'm mentioning these 2 parts first because they're key to the first steps of building this, because I need to do some pre-fitting onto this board here. So far, here's the circuit laid out. It's the thing that I've worked the most on. I still have to finalize the output and power supply module, but this is going to be the control module. This is representative of the button here. This is representative of the potentiometer. Now we are looking at this diagram from the component side. Now the control side, these guys, they're gonna be on the back side. So if I have this marked out correctly, that is my center point. This gonna go right here, and then we're flipping her around. And this guy is gonna go right here. And it's not gonna mount into the board. That's what this represents, the gaping hole. So I need to pilot out these spots, because where these guys go, if I build on this board first, it's gonna be difficult to fit it. So I can mark my positions. Gotta drill a hole in this board. Hey. All right, that's that position, and the button goes in this position. Now I do believe we're gonna have to call in Pressy Boy. Oh boy, time to throw chips on the table. So this fruit button is this big, 912, just almost an inch. Yeah, pretty much we need to make an inch hole in this board. Now the hole in our press table is not big enough, so we need to shim this up somehow. Let's spool it up actually, let's try this. Oh yeah, that's a hole. So switch is gonna come through like this. That's gonna give us room for it. And the pot is gonna go there. That is getting generally mounted onto this thing. Let us show you this thing. So initially I planned to build this in a plainer looking box. You know, like a Hammond enclosure like this. I was gonna buy it in a nice color like red or something, but then I don't know, I decided to go fancier. And I got this thing, also a Hammond enclosure, also supposed to be aluminum. I liked it. It had a very vintage look to it. Kind of reminded me, nostalgic, if you will, of what a train controller box might have looked like back in the 70s and 80s when I saw my brother playing with them growing up. Well, I wasn't alive in the 70s, but I can only assume that what he was using was probably from the 70s. He's the older brother, after all. So yeah, just nostalgic. So this is what I'm gonna build it in. And this circuit board is gonna mount generally here, except knob this side, button that side. I'm gonna have it like down, roughly centered right there. Do believe that should look about good. Okay, well, where's the pencil? No, seriously, where's my pencil? Okay, assuming that doesn't wear off on us instantly. So all radio knobs, what we're gonna be using, a little close together, but it's gonna be fine. I've already designed the circuit around this. I'm gonna establish something resembling a center point here. How do I center square it though? Okay, that looks center right there. Puts our center right here, roughly. Okay, we're gonna cut into this. You know what? I can't drill from this side, so that was absolutely freaking pointless. I can maybe drill this small one here, and that'll allow us to copy our dimensions over to the other side. This is aluminum, so it should work easy. Yeah, not too bad. Actually, that said, maybe I can just pilot the hole like this. How good is that? Pretty close, bud. That hole, oh, slight hysteresis. Okay, well, 1 inch hole going in right here. Oh. Now I need a hole big enough for this potentiometer, 270. Looks about 5/16. Yeah, it's aluminum when you get dirty holes like that. There's gonna be a little bit of slop in it, but that'll enhance our adjustimating. Okay, I think I could fire up just a little bit of heat iron, because I can pre-fit that one component. Now the heat iron has an anti-rotation tab on it. So far we're good in fitment. I think for the first time in human history, I'm gonna use that anti-rotation tab. Let's see if I can pop this through the hole and maybe give it a little score. Oh yeah, there it is. We don't even have to drill all the way through. That's great. Anti-rotation divot is in place. Now if you see, the potentiometer has these little mounting tabs in which I can solder it down to the board. I'm gonna do that so that it stays put, and then our pre-fitting can be complete. I don't think this jaw will open wide enough this way. That's gonna make working on this board hard. We're gonna need a bigger vise. Oh no, just, bud. But either way, there we go. So the pot's hard mounted. So here is the plan. This is 1-inch poly pipe, you know, plumbing, that I've cut to be the same offset as the potentiometer. So we take as a button, we put it in there. We put the poly pipe shim, and then we slap down potentiometer through the hole. And then the idea is we start fastening down the button, and then we can mount the pot. And then there you have it. That switch is mounted through the hole, and that's what the box is gonna look like. Oh, after I clean it up a bit, of course. Ta-ta-ha-ta-ta. Knob, button. And that's gonna have more than enough mounting stability for this entire PCB. Like that's a lot of, this isn't gonna go anywhere once I've got it all fastened down. The only other part is the LED display. So those are right here and right here on the schematic. Represented on the component side here, we need to do a little bit of counting. LED is here. Second LED is right here. We need to transpose those measurements to the other side. I need like a plumb bob here. Okay, well, let's eyeball on it. Right there. And then my dimension this way is like right there. So let's take this apart. Hey, everything's rolling everywhere, bud. I gotta copy those dimensions across. Then we know we're talking right about here. Let's pilot those holes this time. So for the LED indicators, I'm going to be using these things. This is a Russian surplus, probably pretty vintage light bulb holder, kind of like in an old tube amp. Inside, we've got a little screw bulb ready for 6 volts, but I've pushed them as high as 8 without a problem. Doesn't matter, we're not using the bulbs. One flaw of this design is because it's sealed in there, it gets real hot. Fortunately, it's made out of some decent bakelite. But mostly, I take them apart like this, and then I can just put LED leads through those holes, and boom, I've got a little jewel for an LED. Now that's not applicable in this situation because there's not going to be enough depth. We're going to be mounting these over the board as seen here. The LEDs are going to be on the tail edge of the board. So what I'm going to do is, well, I'm just going to cut these apart. Now, I do not like how deep it is on this side. Well, actually, that's not too bad. We could probably use this side, but the thread is identical on both ends, so we could probably leave that snoot into place and then cut this just a little bit longer. We want enough for thread, for a nice firm threading. How deep is our thread? Our thread is 0.18 of an inch. And how thick is our thing? 0.69, 0.7. So 180 plus 70. Really? 250, quarter of an inch. And how much do we have here? 190. I want at least 230, 240, right about there. Let's find a groove that fits in. Oh yeah, bud, right this groove here. How to cut this? Oh, do I feel like making a mess with the Dremel? Oh boy. How far can I get with a hacksaw? Let's try cutting this with a hacksaw. See what happens. Oh, it'll definitely cut it. Cut it straight though? Well, that's up for philosophical debate. And me. Okay, we end up with this choppy pupper, in which my lens mostly will bottom out. So, okay, small victory. Let's do that again. So these guys, you know, they have the outer ring, they have the inner ring. I guess I'm not using these inner rings. Bulb, which came with every one, so they're accumulating. They have the rear contact. Give that a twist, it pops right out. These need a bit of a tilt up. Sucks because you feel like you're wasting, but you're making it better, right? Let's just give a little choppa. Smells like coffee. this one chopped a bit more sloppy. Slop chop, but it threads okay. All right, lettuce and tomato progressively make more of a mess of the shop by drilling more holes. How big of a hole, you might ask? Let's see. 616, 620, 613, 5/8. All right. Is that the right size? 'Tis! So nice, we shall do it twice. Makes me nervous is this thing has such a good paint finish. I don't want to mess it up. I gotta be careful working on it. Maybe I should be taping this off. Well, this is all I'm drilling into it for today, so I guess we can for the next iteration. Oh, look at those silly eyes stuck together. Now these guys have little notches, anti-rotation notches in there also, so we need to carve those out. Use the triangular. That's 1 and 2. So now that means I should be able to screw these into place. I can put torque into them now. Put them nice and tight because I got the anti-rotation. So that should clear the board now. Let's remount our board. Nice. This takes shape. There's definitely clearance out of the board. So the LEDs are gonna sit on the edge of the board there. We're a little sloppy slopperton, but they're pretty good. They could have been a touch higher, but it's okay. The LEDs are still gonna get into those holes, right? So the LEDs are just gonna be hard mounted to the board and they'll just peep through. They'll just peep through and then boom, light this up, button, knob, and that is roughly what the front of this is gonna look like. So that said, now we can build on the circuit board. Yeah. All right, and here it is. I didn't film me perf boarding it because well, I've got other videos of me perf boarding. You should be watching those ones too. It's the next day and I didn't get it all done in one sitting. And I don't know, it doesn't look quite as pretty as it does in the pictures, but it works. Oh, yeah, you know, the back, we have, you know, I wish this looked prettier. Those are isolation holes. I drill off the top contacts. This is a dual-sided perf board, and the holes on one side are connected to the holes on the other side. So where we have bridging connections, we don't want it to short out. So I drill those isolation holes. And SMDs, I like working with SMDs in these applications because there's no pins to work with. You can put component leads through the holes to make the connections. Like the 0.1 UF bypass capacitors on the oscillators, I can use the leads of those as the pins. Now, right there, I got an SMD 4027 and I mounted it on this Adafruit SOIC-16 adapter. If you use those, you gotta be careful. They're double-sided. They have exposed contacts on the back. You need to put some Captain tape or some isolation on the back of these guys. I like using these guys if I can because their width gives me more room to run channels underneath of them. Seen here. I salvaged connectors off old fans and off old motherboards for some of the connections. That's to connect the switch. This one's to connect to the output module. That's going to provide the phase signal and the enable disable signal. And then this one connects to the power supply board to feed the PWM signal to get the voltage feedback for the enable disable circuit and obviously power for the board. Regulation is built onto the board. From the schematic, very subtle changes were made. Over here on the input and output, when you're using a linear regulator, they tell you to put 0.1 UF on the input on top of the bulk if your power supply is going to be more than a few inches away from the regulation point, which it is because there's a big long wire. And then also you typically have a 0.1 U on the output too. That was already in the design, but I forgot to draw it on the schematic. So yeah, we got those doubled up right over here. And then I adjusted the PWM. I was only getting about 150K with a 220p on its input. I wanted more like 200, and just going 100 gave me like 300. I actually added a 47p along with a 100. 147p is giving me about the 200, just over 200, 220 kilohertz. That's my target. I don't have anything between 100, 47, and 220 in stock, so I had to do that. The switch button, well, it has a common positive, and then again, I used a fan connector. These connectors are actually balance charging connectors for batteries, lithium ion packs. I had a bunch of these in stock with their other side. I bought some for doing balance charging packs at one point, and you got a bulk amount of them, never used them. Oh, finally, they're coming in handy for here. So now this should fit right on there, just like that. Slide our button shim into place, pop our button through there, screws that down. There's no anti-rotation on this one, so you have to kind of hold her steady. I'm gonna fasten down the pot. And you know what, just for apes and options, I'm gonna put the knob on. Now we should be able to do a basic function test to this. I wanna do that. I'm just gonna put in the crystals here first, the AS393, even though I don't know that I need it for this function test. Well, get that on there. And then the button, well, it's gonna plug in right onto here. Haha. All right, so let's bring in our main board. This main board's gonna get some power, so we're gonna ground out disabling the output section, and we will ground out disabling the power supply section. So those will be inert. I'll plug in the power here, and now we should just be able to jumper this over. So if I put some negative into this pin, some positive into this pin, turn it on. Ooh, that does not look promising. Oh boy, my LEDs aren't lighting. Yeah, I was worried with how tricky this guy was. I was gonna have to do some troubleshooting. I'm gonna fire up Electrovision over here, see if we can probe on some of our signals just to confirm that stuff's not like completely screwed up. We have a faint blinking on that, which tells me that our clock signal's theoretically working. Blue should be PWM. Okay, good news is our PWM is working, though we're getting exorbitant pulsing. Yeah, 200 kilohertz. And roughly the duty cycles that we need. Oh, and this knob's nice and smooth. So PWM's working. Press the button, weird stuff happens. But not light from our LEDs. Let's see if it's suppressed by the lack of voltage feedback. Let's apply voltage to the op amp. Detecting voltage, the light goes out. So that op amp's doing its job. That means we're getting a disable signal. Oh! It's one of the first times one of these circuits didn't immediately work right away. The fact that we're getting that faint blinking telling me the clock signal works suggests that our regulation should be working fine, our 5 volts. If it wasn't, that little HC114 I'm using would have fried. Where would that be? Hey, what is this? Oh crap, our regulation isn't working. Okay, or no. What? I'm getting 5 volts here. No, I'm getting correct voltages. Okay, so for some reason I'm getting 18 volts to the LED. Okay, what did I do wrong here? Okay, troubleshooting. Oh, you know what it was? I put the knob on. Them's are the rules. Never put the knobs on before you've tested it. It never fails. Whenever I've put the knob on something before I've tested it, that's when there's a problem. It's just bad luck to put the knobs on before you've tested it. Oh, my LEDs aren't dead. One of the absolute hardest parts about perf boarding is the pain in the arse and if you have to rework it. I gotta pull that regulator out. Most of the components used in this assembly were the same ones that were on the breadboard, which means most of the components used in this assembly are validated. But I used a regulator that was just kicking around, and it's possible that it got damaged in a previous situation. Because I had a failed project there, and I scrapped it. And this is one of the parts from that project, so maybe this is why that project failed. Ah. Oh, I found another problem. I have a power bus that's not connected. How herpy-derpy. Ugh. Right here, that little connection right there I forgot to make, which is maybe good because I would have fried one of my oscillators. I swear, man, if you blink, you miss it. Gotta do a little bit of sloppy patching here now. Sorry for not adjusting the camera. I'm just kind of getting in the zone here. That means our flip-flop wouldn't have even been working. How the frick am I gonna cut this off now? Ugh, how am I gonna get a fresh regulator in there? Pokey holy. This build will forever be tarnished. All right, fresh regulator going in. We've just made this sloppier. Oh man. Now what happens if I give it power? Is it going to instantly burn out because there's something else wrong? Let's set up our voltage detector here, connect it to the pin. It's good if it puts out positive voltage and... Oh. Okay. Oh yeah, that regulator is getting hot. Okay, something's shorting out in here and freaking burning our thing out. Man, the PWM was still working. PWM was somehow pulling power from somewhere else. So this rail is connected to there. It was pulling power through here somehow because other things were connected to the positive bus right here, the LEDs. How the heck would that be getting power? Okay, well, it looks like I got some work to do. I'm gonna have to look over this thing with a fine-tooth comb. Okay, but it's been a couple hours later. I got it working now. It's really stupid what was wrong. You know, just like I forgot this link to connect the positive power rail to here, I also forgot this link right here to connect this ground bus. So that's why the LEDs weren't lighting up, because they weren't getting any ground supply, and neither was the regulator. And if the regulator doesn't get ground, the regulator doesn't regulate. So as soon as I hooked the power up, well, my 1G14 down here, it got 18 volts, it fried, and when it fries, it shorts out, pulls the entire system down, and starts overloading the regulator. It turns out both regulators were fine. I didn't damage the regulators, but I did damage that 1G14. I replaced it with a TC4 because I have more of them in stock, which is good, because at some point in this hectic mess trying to diagnose it, I accidentally connected a wrong wire, and I fried that TC4. I accidentally plugged the voltage feedback into it and shot 14 to 20 volts into its output. The next time in another testing process, when I went to hook it up to the power supply, I accidentally grounded out the input. I fried a second TC4. I found out that my AS939 was on thin ice, and I should have had a current limiting resistor on its input here, which I do now, because when I connected it to the 20 volt rail to test its function, it fried. That's two TC4s, a 1G14, and an AS939. Yeah, I'm glad I didn't fry any of my one-off components. Like the 4027. Fortunately, it's all set in there. I can't accidentally hook it up wrong. And fortunately, my LEDs, well, they couldn't fry because they didn't have a ground rail when I accidentally juiced the thing with 18 volts. Oh yeah, and I also fried a 5 volt power supply. When I was diagnosing it, I removed the regulator, brought everything down to 5 volts, and then at some point I reconnected the 20 volt supply, forgot to disconnect this one. It was unplugged, and I'm just sitting there and I hear, oh, I backfeeded 20 volts into this thing. That's why I don't do this professionally, folks. This is all hobby craft right here. Me tinkering with experiments. And heck, I didn't even know how to do most of this stuff like 2 months ago, so you gotta give me some credit here. I'm having fun. At least it's not a $20 BQ 2031 that I fried twice, and another experiment that I've abandoned. But nevertheless, it seems to be working now, and I'm gonna do a proper function test. I think it won't be bad luck to plug in the actual knob this time. Plug in the knob. Things get hectic and you start, you know, tacking things together, just jumping stuff together, and you get your wires crossed. And next thing you know, you accidentally connect an input to an output and an output to an input, and hilarity ensues. It's funny, you think you got one problem figured out, and then you accidentally make a mistake somewhere else, and you get another component failure elsewhere. Especially as you get frustrated, you're not paying as much attention, right? I didn't even put a fresh regulator in there, I put one of the old ones back in. You know, it's funny because the 1G14s, the HC114s, they can handle a lot of current dissipation. So they're hardy in that way, but they can't take overvolting. The TC4s can handle higher voltages, but they have very low current dissipation. So much to the point that if you ground out their output for a second, done. Okay, carefully now, carefully, I said carefully, bud, let us reconnect what's going on here. PWM goes to here. I have the power supply reconnected. Power's off. PWM is the blue line. Voltage reference is the green line. Yes, voltage reference goes to the output rail here. Obviously black is ground, and then orange is 20 volt input. I'm nervous just to turn this thing on. Let's take a moment to double check here. Make sure I don't have PWM accidentally grounded out again. No. Positive and negative are correct. I know the regulator's working now. Voltage reference is over there. Ha. Ah. And the PWM's connected, so as soon as I turn this knob, now there's no load, so I turn the knob down. It's gonna take a couple seconds for the voltage to drop in the power supply. There it goes. Jom, jom, jom. Here, we'll go here. Turn that up a scotch. get the command changeover ready, let go of the knob, and then when that light comes back on, it switch over. Switch over. Bomb. Okay. Ooh. You know, AS-39s are cheap, fortunately. Now let's try it with the train. This will allow us to double check our phases. Not that that matters, there's no marking on the train itself, so we could just cross wires. So these are the outputs for the train right there. And then here's our output control right here. Except now I forget what's what on this. White and green are the phase control. I do believe green should be primary, white should be secondary. And then finally, black is the enable disable. Okay, I think everything's hooked up good. Okay, our phasing is backwards. Okay, good. We're out of the water. I've already tested the power supply. I know it's limiting 14 volts. And those lenses, see, they would have been dimmer with the normal LEDs, and the green's still much brighter, but they're not blinding me. So they're gonna do. They're gonna do, and they're gonna look nice. That's backwards. That's forwards right now. That's just a case of making white primary phase and green secondary phase. Again, not a big deal. The rest of the circuit doesn't care what polarity stuff is. I don't know if the camera's picking that up, but... the button's mostly reliable. And I know what you're thinking. Maybe I want that light to be on when the train's rolling. Oh, I'm sure that could be done. But the way I see it, when the train's rolling, you're looking at the train. So bling, we interact with that when we're not interacting with the train. So my engineering and my concepts, it's all correct. It's just a case of if you blink, you miss it while assembling this thing, because there's a lot going on, a lot to keep track of. If it takes a long time and it gets late, you start slipping up. But then even if you pause and start the next day, you might get lost. Oh boy, draw an excuse box around me. Either way, the control board is done and we've pre-fitted. That is the end of this presentation. For now, for today, I still have to build the power supply module and the output module and get them hammed on there. The power supply module's mostly designed. I think there's a couple, I just gonna have to double check. There's a couple more capacitors I planned on adding to this. And then that is the output module using the original IXDD604. I need to update this design, especially I changed the connectors since, so I still have to finalize these designs. This one's pretty much ready to go. I think I can build on this one very soon. So stay tuned, because soon we'll be continuing this project. And if you've watched this far, obviously you're interested and you're gonna want to see the rest. So I still have no idea how to end these things sometimes. And holy frick, this project was a doozy. When did I come up with the idea for this even? August. It's the end of October now.